Our research presentation is about analyzing the political sentiment of Indic languages through using transformer learning. Short introduction about me. I am an artificial intelligence researcher. My focus is the applications of AI. My past work has been in political science, healthcare infrastructure, and chemistry, all relating to AI. Currently, I'm affiliated with the Artificial Intelligence Coalition as the vice president. This is my contact information. So a lot of things are use sentiment analysis, opinion mining now. For example, you can determine the emotion expressed in text, and there's a lot of wide range of applications like understanding public opinion. You can gauge customer satisfaction, or you could analyze political discourse, which is what this research aims to do. It has previously been proven that political sentiment analysis is very effective at predicting election results, specifically with Western elections, especially in those Western elections, national elections where you're trying to get national leaders. Additionally, it also has been proven in local policy-based elections as well. The question we propose is, could this be extended to other nations where English is not necessarily the primary language? With that in mind, we look at our specific use case, which is the elections of Karnataka. Karnataka is a southern Indian state, and the primary language spoken there is Kannada. If you look at it briefly from a political perspective, the state is controlled by the Bharatiya Janata Party, and this is currently the ruling party in India. And so because of that, this state is actually considered a regional stronghold of the party. In May of 2023, there were state legislature elections that occurred, and people elected their legislative members of assembly directly. Basically, we use the given that majority party affiliation determines the victor of elections. And we can see that because the Indian National Congress actually beat BJP in this election, the National Congress being the primary opposition party in the nation of India. The ratio of Congress to BJP was 135 to 66. And so what we want to essentially do is use this online sentiment usually found through Twitter analysis that's usually in English and apply it to the Kannada language or other languages that are spoken in this state of Karnataka. We also know that Kannada isn't the only language spoken in the state. We know that the national language, Hindi, is also commonly used, and local dialects and neighboring languages are also prevalent as well. This can also be seen on social media. We can see that traditional models might not properly analyze Indic languages because they were not specifically trained for that use case. And so we think that larger, more impactful elections might be affected by this shortcoming of these models. So we want to use this election and its predictions to also find its relevance to the national Lok Sabha election of 2024 as well. We also think that analysis of state elections, like I mentioned previously, could potentially aid in fictional analysis of larger elections in the nation. When we look at artificial intelligence and sentiment analysis, we can see a lot of previous precedent for using natural language processing and other approaches. In terms of traditional approaches, we can see that SVMs, naive Bayes, and maximum entropy are very successful in predicting sentiments. And especially with regards to deep learning, RNNs such as LSTM or GRU are very successful as well. CNNs have recently been proven very useful in this sentiment analysis. And with this, transformers also comes in. We have BERT and XLNet, GPT, all these transformers trained on different sets of data with different parameters is leading to much better sentiment analysis that can be used for a variety of better applications. So coming to the goals of our study, primarily we want to collect balanced data on the elections. We then want to analyze general sentiment of parties over time. And finally, we want to accurately predict election results. Coming to our methodology, we started by gathering data from Twitter using the Twitter API, and we had our team label sentiment by hand. We then augmented the data as needed to create a more robust training set. After this, we analyzed data for general trends, both manually and through machine learning, trying to find common themes and looking for trends over time. Using this, we trained the transformer models on the data and tuned the hyperparameters, and we were able to predict the election results with the models. As I mentioned before, the tweets were collected from the Twitter API. We also collected geophysical data just for our reference, but did not collect any identifiable data. In terms of augmentation, we used a method called random swap, which basically takes two words in a sentence that are swapped n times. And the higher the number n is, the more generalized data you will get because of the varying sentence structure. We also used a proven method of using Google Translate, where you translate some English language tweets into Indic languages and sometimes translate it back into other languages as well to increase the robustness of the data set because you have more multilingual tweets. Using this, the model is able to better generalize trends within the languages as well. Our data was labeled by a group of researchers, and the Cohens Kappa score was 0.813, which by the metric actually indicates substantial agreement. We labeled the data with three labels, with yes denoting pro-BJP tweets, no denoting pro-Congress tweets, and comment denoting questions or data that doesn't really have an affiliation with either party. With regards to sentiment analysis, we did some manual analysis, starting with generating word clouds. This basically finds and displays the most common words in the data. We actually did find that the neutral words were most common, which could be expected because these are just words you need to communicate in general, like people, election, vote. So we removed that. And once we redo that, we were able to see which issues were emphasized more by each side. So if we look at the pro-Congress word cloud, which is up here, we can see that there are words like Hindutva. There's a phrase in the Kannada language, which basically is a slogan for the Congress party in that state. And so these are all things that Congress focuses on, Hindutva being an ideology that Congress is very against. So they like to talk about it a lot. When you look at the pro-BJP side, you can see words like stranded and Dr. Jaishankar. These are Dr. Jaishankar being a prominent leader in the party, stranded referring to a specific political issue that occurred during prior to the election. So we can look at what policies and what specific events these parties are focusing on with regards to the election. We use this data and other data as well to create a timeline of sentiment. So we found the relative sentiment, basically taking the ratio of pro-BJP and pro-Congress tweets, and we organized it by date. The average value of this ratio was 0.95, which indicates that there were more pro-Congress tweets in this data set compared to BJP. What's interesting is this ratio increased to 1.37 on April 18th to 20th, which is when a controversy negatively impacting Congress was very prominent, and BJP did gain a little bit more traction, is what we found. We also found that there were like slight fluctuations just based on other events that were happening in the state and on social media with regards to these parties. And we can use that to actually see a clear trend in which party was trending at which time. And we can also see that finally after the election happened, we had 0.89 as a ratio. That's probably because Congress, like I mentioned before, won in the election. Going to the technical aspect, we used a lot of different transformers in our training. We started by using BERT, which has bidirectional capabilities, which means it has masked language modeling. Indic BERT, which is BERT, but actually trained on 11 Indic languages, which is very useful for our specific use case. Roberta, which is using dynamic masking instead of static masking. And it was also trained on a larger quantity of data than the main BERT, and so this actually increases robustness. XLNet had a completely different architecture, but it had a very comparable performance to BERT. Deberta as well has a disentangled attention mechanism and an enhanced mask decoder. Both of these were actually useful to our use case. With regards to our hyperparameters, we're basically kind of just adding new layers to the existing transformers that are there. Our learning rate, we used 1 times 10 to the -5 to 1 times 10 to the -3 as our range. Specifically, we just wanted steady progress. We optimized that instead of having a faster convergence because we were really focused on trying to get this optimal like learning rate. With regards to our batch size, we had 8 to 64. We wanted slightly faster training, and we did have the memory capability, so we decided to go with a little higher version. With regards to hidden layers, we have a range of 2 to 4 hidden layers, just because that's pretty standard with transformers and things of that nature. Attention heads, we had a range of 4 to 16. And this is just trying to find that balance between performance gains and computation costs and like fine-grained analysis and better contextual understanding. Dropout rate, we went from 0.0 to 0.1, which is pretty standard to regularize the training and prevent overfitting. With regards to our training epochs, we did use a very wide range of 5 to 50 just to see how this works. Once we found the optimal other hyperparameters for each model. The results obviously differed for various models. There are different hyperparameters as well. The optimal number hovers somewhere around 20 epochs for most models. And we can see that the global maximum is somewhere between 18 and 25 for all of the models anyway. So that's just something to be noted for the future. Coming to our results section, we can find that fine-tuned models that were tested on a subset of multilingual tweets just taken from what we scraped from Twitter found that the best overall model was Indic with a 0.87 accuracy and an F1 score of 0.92, which means it has really good accuracy, but it's also very balanced in terms of the model in predicting different categories. We also found that the highest accuracy was actually BERT because the accuracy was just slightly higher, but the F1 score was considerably lower than that of Indic BERT. So we were able to come to the conclusion that Indic BERT was more balanced in this prediction. We can also note that all models, regardless of how well they performed, actually did much better than the baseline of 0.36. So that is also something to be noted for the future. We also gave these models 100 separate tweets that were not used at all to classify in order to predict the winner of the election. So basically, we took what it predicted and calculated the ratio of no to yes to find the ratio of Congress to BJP. Using that, we can compare it to the actual predictions that happened in our given sample size. And we can use that to see who it would predict would win. Just to do this, we removed the neutral predictions just because it would not add much to the calculation. And so looking at the relative amount of what it predicted, we could predict who it thought it would win. The actual ratio, as mentioned here, is 65 to 24, Congress to BJP. Indic BERT's prediction was really accurate, 62 to 18. And obviously other models were also somewhere along the line, some more closer than others, of finding the ratio between Congress and BJP. Regardless, all of them were able to predict that Congress won by a landslide. And so this is to show that our model actually does work in predicting the results of this election. With regards to some discussion of our results, we found that implication relevance to Indian politics, basically we have an accurate prediction of sentiment that can help in political decision-making. And Indic BERT and other models can actually help analyze sentiment in non-English speaking countries. Obviously, Indic BERT for India and other related countries. And there are certain other fine-tuned versions of BERT and other transformers that would definitely work for other countries as well. We've proved that there's improved sentiment analysis. So political parties can gauge public opinion and tailor campaign strategies. They can also adapt messaging and outreach to align with prevailing sentiment. This also helps them identify key issues and prioritize policies because they have real-time reactions on social media to inform policy alignment with public concerns. They can identify larger sentiment drivers such as economic issues, social justice, or governance. All of these things that are important to these parties could be done through the use of these transformers in AI. Finally, this would just lead to targeted campaign strategies because you can use augmentation to get a much better sense of what your voter base is like and design targeted campaign strategies based on the nuanced sentiment analysis. Looking at some future areas for improvement, we definitely want to include more NLP models, possibly look at model stacking and things of that nature to look for more improved sentiment analysis. Another thing is we want to look at multilingual sentiment analysis to address linguistic nuances, which means we don't want to necessarily include as much English tweets that we have included in our actual data set, just because we want to focus on these specific regions as well, where English might not be the best language. Even though we have done that, we want to do that at a more nuanced, kind of a more advanced way. We also want to incorporate more contextual information for accurate sentiment analysis. This is because like geographic location, demographics, and age have all been proven to be predictors of a person's sentiment analysis at times. And so if you add more layers to the model overall, stack another, just a regular neural network that analyzes these without the text, you could probably find more accurate sentiment analysis. Another major issue would be to possibly consider potential bias in the user base, Twitter, and explore other platforms that might be used by more voters, such as Facebook or WhatsApp, for example. This is because it has been shown that the average age of the Twitter user is lower than that of Facebook and WhatsApp. So that means you have this gap between the users and you're only looking at a specific portion of the population at times. Another issue that was pointed out further in our research was there's a change in attitude between local and national elections at times in countries where there are more than two parties that are prevalent. And so we could definitely account for that when trying to apply the results of this election to the national election, as I had mentioned previously. Looking at our conclusion, the significance of our study was that we were able to apply political sentiment analysis to inform political strategies, identify voter concerns, and tailor messaging. With regards to transformer-based models, we have a bunch of models such as BERT, Indic BERT, Roberta, XLNet, DistilBERT, DiBERTA that captured semantic nuances and contextual information. We were able to also find a deeper understanding of sentiment expressions in the diverse linguistic landscape of the state of Karnataka as well. With regards to data augmentation, we found that data augmentation methods properly address bias concerns and ensured a more or less balanced representation of opinionated and neutral tweets. We also found that it enhanced representativeness and generalizability that contributed to the robustness and accuracy of the models. Thank you for listening to the presentation. If anybody has any questions, please let me know or just put them in the chat.